so this is the last section of our radicals and rational exponents. We're going to deal with solving radical equations. So in this section, we're going to learn to solve radical equations. An equation containing a variable and a radicand is a radical equation. Some examples are listed here. So we've got square root of p equals 7, cube root of n equals 2, square root of 2x plus 1, and then plus 1 outside of that equals x. Those are examples. So now we're going to understand how to solve for this. Okay, so understanding the steps for solving a radical equation. So the procedure we have listed here is 6 steps. Okay, so we're going to get a radical on a side by itself. Then we would need to square both sides of the equation to eliminate a radical. Combine like terms on each side of the equation. If the equation contains a radical, repeat steps 1 through 3. Solve the equation and check the proposed solutions in the original equation and discard extraneous solutions. So, extraneous solution is a value that satisfies one of the new equations but does not satisfy the original equation. Extraneous solutions occur frequently when solving radical equations. So we must check all possible solutions in the original equation and discard any that are extraneous. So in other words, when we get a solution, you can go back and check to make sure it actually works in the original equation. So let's say in one of those, let's say the 2x, square root of 2x plus 1 equals x up there. So we got, let's say we were to look at this one right here. And let's say that we get that x equals 2. Well, after solving for that, so then we'd have to go back and put x equals 2 back in this original equation there to see if it checks out. And that's what it's talking about doing, okay? All right, so let's do some examples. So in this first one here, we got square root of b minus 8 equals 2. So how are we going to do this? Well, our first step is we're going to take the radical that's on one side by itself. And it is already, so we're good, right? Our second step is we need to square both sides and eliminate the square root. So let's do that. Let's go ahead and square both sides. So now we've done that. That gets away the radical, right? It takes away the square root symbol. So now we just got b minus 8 equals, and then 2 squared is equal to 4. So let's see what we can do here. Well, step 3 and 4 says do not apply because there are no like terms to combine and no radicals remain. So that eliminates those 2 steps. So we got a couple more to work on. So now we just need to solve the equation, right? So let's solve that equation. We've got b minus 8 equals 4. So let's add 8 to both sides. All right, so to do that, if we take that add 8 to both sides, so we would get, I'm going to write it on here for us. Let's say we add 8 and we add 8. We should get, those guys should go away. We should live with b equals 12. Okay? So now then we can, our last step, right? We wanted to check to make sure that the answer we got works in the original equation. So we're going to see if 12 works in the original equation. So we're going to plug it back in the square root of b minus 8 equals 2. Okay? So in which case we would get square root of 12 minus 8 equals 2. Well, 12 minus 8 is 4. Square root of 4 is 2. So 2 equals 2. So we're good. We got a check mark, right? We're all good with that. So the solution set is 12. So we're good on that one. Now let's look at another example. So we got the square root of w plus 3 and plus 7 outside of that equals 3. So let's see what we got to do here. So for this, take our first step, right? Let's get that radical on one side by itself, okay? Let's do that all by itself. So what we need to do that? Well, we need to subtract 7 from both sides, right? So we're going to do that. We're going to subtract 7 from this side. So I'm going to write it over here. So we're going to say subtract 7, and we're going to subtract 7 from here. in which case the 7's will go away on this side, and 3 minus 7, of course the 7 is bigger and it's negative, so we got a negative 4, okay? Now we have a radical on one side already, so now we just need to square both sides to eliminate it. So let's do that. So we square both sides, and we should get w plus 3, and then negative 4 squared. Negative times a negative gives you a positive, and 4 times 4 is 16. Okay, so now how do we get rid of this 3? Well, we're going to subtract 3 from each side. Right? We're going to take 3 from both sides, in which case we'll be left with a w on the left and a 13 on the right. So now what we do was our last little step there. Now we've got to check to make sure that 13 works for the equation. So let's see if it does. What's our original equation? We got square root of w plus 3 plus 7 equals 3. So we're going to put 13 in the place of w. So when we do that, now as you can see, we should get square root of 16 plus 7 equals 3. Okay, so now what's the square root of 16? Well, if you break that down, right, say 4 times 4, so then we can take a 4 out of there. So a 4 plus 7 equals 3. Well, 4 plus 7, that's 11, right? So does 11 equal 3? No, 11 doesn't equal 3. So again, that's what they're talking about us to check. Even though we got an answer that seemed to work out for us in this case, because that was w equal 13, it's extraneous solution. So the equation has no real solution. So there's no real solution to that problem. However, we did get w equals 13. So that is what that's talking about. All right, so again, the solution set is 0. We have no solution technically for that one. Okay, so let's do another example. Same one here, or same style, I should say. So we got square root of 2y plus 4 minus 2 equals y. So if we're looking at the solution, let's get that radical by itself, right? Okay, so what do we got to do to do that? Well, we're going to need to add 2 to both sides, right? So we add 2 to both sides. So let's say we add 2, add 2. So these guys should go away, and we should have the square root of 2y plus 4 equals y plus 2. All right. So now let's square both sides, right? We want to get rid of this radical. So square both sides. So if we square both sides here, now we just need to simplify the square. I'm sorry, simplify and square the binomial right there, right? So we got this guy. We got a y plus 2 squared. That's not just y squared plus 2 squared. That's y plus 2 times y plus 2. So don't get confused with that, okay? So again, over here on the left, that's radical goes away. So we're left with 2y plus 4. And then they went ahead and worked this out. Again, what they did, they took y plus 2 times y plus 2, right? So did the FOIL method. They just did it really fast here, and they didn't put this step in this little slideshow here. So if we took y times y, and then y times 2, so it gave us y squared plus 2y, and then inside is 2y. And then 2 times 2, which gave us 4. So then they just combine the 2y plus 2y. Okay, so now let's go ahead and let's see what we do, and let's go ahead and subtract this 2y. Okay, so we'll subtract the 2y from both sides. And then we'll subtract that 4, right? In which case, these guys will go away altogether. This 4 will go away, and we'll be left with 0 equals y squared plus 2y. Okay? So now let's factor, right? Because we can take a y out of both of these. So we take a y out of both of those. y times y will give us y squared, and then a y times just a 2 will give us 2y. So we have y times, in parentheses, y plus 2. Now when you have that and it's equal to 0, now we can set each of those equal to 0. Okay? So now we can take y equals 0 or y plus 2 equals 0 and just solve for them. Okay? And of course, y equals 0. And then to get this y by itself here, we're going to subtract 2 from both sides. In which case those 2's will go away. Sorry, that was a bad looking 2. Subtract 2 from that side. So we have y equals 0 and y equals negative 2. In our last step here, what we do, we go through, we got to check the original equation here. So our original equation up here is what they're talking about, right? So we're going to plug in a 0 and see if it works. And then we'll plug in a negative 2 and see if it works. So our original equation right there, let's plug in that 0 first. So if we plug in the 0 for that, we got square root of 2 times 0 plus 4 minus 2 equals 0. Square root of 4 minus 2 equals 0. So that's 2 minus 2 equals 0, which means 0 equals 0 because 2 minus 2 is 0. We're all good. Let's see about the y equals negative 2. All right, so we're going to go ahead and plug this in. We already plugged in the negative 2 on this y, so now we got to plug in a negative 2 on that one. And let's go ahead and do the math there because we just plugged in those negative 2's. So we should be left with a negative 4 plus 4 minus 2 and a minus 2. Well, this is going to go away down to 0, right? Square root of 0 minus 2 equals negative 2. Square root of 0 is 0. So negative 2 equals negative 2, and that works out as well. So the solution for this guy, of course, is negative 2 and 0. So we're all good. All right, so let's do another example here. Now, we got a nasty one here, right? It's got two radicals in here. We got square root 3b plus 4 minus 2 times the square root of b minus 1, and that equals 0. So to do this one, let's get a radical on one side by itself. Okay? Well, we've got both of these guys, right? So to do this, let's go ahead and add this 2 times square root of b minus 1 to each side. Okay? Let's get it over there. Have 1 on each side of the equal sign, I should say. So to do that, we got this set up right now. And we can square both sides. It'd be easy to square both sides and get rid of those radicals. So let's do that. Square both sides to eliminate the radical. So if we square both of these, the radical goes away. Now be careful. Over here on the right-hand side, this exponent is going to go here and here. Okay? So in other words, we should get 4 times b minus 1 over here on the right-hand side. So we got 3b plus 4, and then equals 4 times b minus 1. All right. So now let's go and distribute that 4 inside the parentheses. So we're going to take 4 times b, which will give us 4b. And we're going to take 4 times negative 1, which gives us negative 4. So we should get 4b minus 4. And we do. Okay. So now we just need to solve the equation. Solve for b here. So what we need to do, let's go ahead and let's subtract, since 4 is bigger than 3, let's go ahead and subtract 3b. So we have a positive b value. And let's go ahead and just add 4 to both sides. So the 3b's go away. The 4's go away over here. So we should be left with 8 on the left-hand side equals, and then 4 minus 3 is 1. So we just have b. So 8 equals b. And we do. That's what we get. 8 equals b. Write this 4 a little bit different. I don't want to get things confused with everybody. So 4 plus 4 gives you 8, okay, equals b. All right. So now, what do we need to do? Our last step is to check to see if 8 works in the original equation. So there's our original equation, and let's plug in an 8 for both of those b's, in which case there they are. And now let's just do some little algebra math here and solve for this and see what we get. So over here we get 24 plus 4 minus 2 times in the square root of 8 minus 1, which should give us 7 over there. We have 28, square root of 28 minus 2 times square root of 7 equals 0. So now we can kind of break this down a little bit. We can break down this square root of 28. Okay, we can say square root of 4 times 7 gives us 28. So let's see what that looks like. All right, so we'll get our square root of 4 times 7 minus 2 times square root of 7. Now look at that. If we do this and say square root of 4 times the square root of 7, well, square root of 4 is 2, right? And then we'll still have a square root of 7. So then that would be 2 square root of 7 minus 2 square root of 7 equals 0. This looks like it's going to work out pretty good, huh? So again, we have 2 square root of 7 minus 2 square root of 7. Well, that gives us 0. That equals 0. So we're good. This works. So the solution set is 8. Our answer for the B is 8. Okay, let's do another one here. So we're going to square and simplify this guy. So remember, this isn't just distributing in. You're not taking this 2 and putting it on each one of these. That's a no-go. We're not doing this. No, 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 no. We're not doing that, okay? This is taking 6 plus square root of r plus 1 times 6 plus square root of r plus 1. All right, so we can use this little formula here, right? So a plus b squared, we can write this out by saying a squared plus 2 times a times b plus b squared. So in this case, our a value would be 6, and our b value is square root of r plus 1. So we take this equation, and of course we substitute in the 6 for an a and square root of r plus 1 for b, and then write out that equation, just like it's shown right there. So with that, now we just need to do a little math and figure this out and multiply through, right? So we should get 6 squared. 6 times 6 is 36. 2 times 6 is 12 times the square root of r plus 1. And then we have the square root of r plus 1 squared. Well, that just takes care of the radical. So now we just need to combine like terms. So we should get the 1. All right, so we're taking this 1 right here, and we're going to add it to this guy. So that gives us 37, and that is our final answer. So nothing else to do with this guy. All right, so let's do another example. So now we're going to solve the equation. So with this one, let's go ahead and take this guy and let's subtract the square root of c on both sides. Okay. So if we do that, again, we're saying here we're going to take this c right here and subtract it from over here. Okay. So these guys go away. And we're left with negative square root of c minus 9 equals 1 minus square root of c. So be careful. Don't forget about this negative right here. Don't forget about this. A lot of people like to drop off those negatives, but don't forget about it. So now we need to divide by negative 1 on both sides. So we need to get rid of that and make sure it makes things a little bit easier. So if we divide by negative 1 on both sides, that'll give us a positive square root of c minus 9 equals -1 plus square root of c. Okay, so now let's square both sides. Because now we have a radical on each side. And again, we're going to square this whole thing here. We're going to square both sides. Okay, so over here, I'm sorry, on the left, that gets rid of our radical. And then we can use that little formula that we just talked about previously in the previous example to handle this setup on the right hand side here. So remember, it was a squared plus 2 times a times b plus b squared. So our a, we can say is, in this case, say a is -1, and our b is square root of c. And if we do that, that'll give us this equation right here. So now we just need to simplify. So if we do that, we should get a 1 out of this, so take care of the negative, minus 2 square root of c plus c. So we get c minus 9 equals 1 minus 2 times square root of c plus c. All right, so let's notice the equation still contains a radical. Therefore, we got to repeat steps 1 through 3. So we need to take care of this by getting the radical by itself on one side. So to do this, let's subtract 1 and c from both sides. So in other words, let's take this, subtract 1, and subtract c from both sides. Subtract 1 and subtract c. Well, that not only takes care of the c's over here, but it's going to take care of the c's over here as well. So take care of these 1's. So we should be left with -10 minus 2 times the square root of c. So -10 equals -2 times the square root of c. So let's divide by -2 on both sides, and then we can square both sides. So we're going to take this and divide by -2, where we get rid of this guy, and we're going to divide by -2 over here. So that should give us a +5 on the left, and just a square root of c on the right. So now we just need to square and simplify this, right, to get rid of that radical. So if we square both sides, the radical goes away on the c, and 5 times 5 is 25. And that is our answer. Now, again, you can go back through and check this if you'd like to, but we're going to say c equals 25, but you can set up for this. The solution set is 25, but you can go back and check that if you'd like. All right, so we'll do one more example here. Instead of having just a square root, we'll do it with a cube root. So we'll take this, say cube root of 7a plus 1 minus 2 times the cube root of a minus 1 equals 0. So to do this, we need the steps that are used to solve equations containing square roots can be used to eliminate the cube roots. Except to eliminate the cube root, we cube both sides of the equation. So again, you cube it instead of squaring, okay? So let's take this. Let's go ahead and solve this guy out. So what do we got to do to get the cube root on the left side and the cube root on the right side? Well, let's go ahead and add 2 times the cube root of a minus 1 to both sides, okay? So if we do that, we get this setup right here. And now we can cube both sides to eliminate the radicals. Now with this one, if we do that, set this up, remember this cube over here goes with the setup of the 2 and the cube root. So this goes on this 2 and on the cube root, okay? So when we do that, 2 cubed is 8, okay? So we should get on the left-hand side, 7a plus 1 equals 8 times a minus 1, okay? So now we can distribute that 8 inside and then subtract. Well, let's do it. If we distribute the 8 inside there, And then we can subtract 7a from both sides and add 8. Right? So with that, what we're talking about here, we would get 8a minus 8. Okay. So now we can subtract, since this 8 is bigger, we have a positive, we can subtract 7a from both sides. And then I get rid of those guys. And we can add 8. So we have a on one side and the numbers on the other. So we should get 9 on the left, and 8 minus 7 is 1, so we just get a. So 9 equals a is what we should get. And that's what we got. So now we need to do our last step, check to see if 9 works in the original equation. So there's our original equation we have. We plug in a 9 to these a values right here. And then we just simplify. So 7 times 9 is 63. And then we have 63 plus 1 inside the first cube root, minus 2 times the cube root of 9 minus 1. So we should have cube root of 64 minus 2 times the cube root of 8. So equals 0. And the cube root of 64 is 4. And the cube root of 8 is 2. So we should get a 4 minus 2 times 2. Well, that's 4 minus 4, which equals 0. So it works out. So solution is 9. It does work for us. All right, guys. So that's how to go through with solving for the square roots and cube roots for the radicals. And I hope you learned a little bit something that helped clear things up on how to go through the process of solving for them. And I'll see you next time.